So this series of questions that we're going to solve now has this shape here. A to the x equals c, where x is a variable in the exponent. And the way that we're going to solve these is by taking a logarithm of both sides. So we can see here we went from a to the x equals c to taking a log of both sides, used the power rule for logarithms to bring the x out to the front, and then just divided by log of a. So this was able to get us to our result here. So let's look at a couple of problems where we actually use this to solve given problems. On number 1 here, we've got 3 to the x equals 100. We'll take a log of both sides. I'll go ahead and use a common log. Log of 3 to the x equals log of 100. Bring the x out front. X log 3 is equal to log of 100. And then I'll divide both sides by log of 3. So x is equal to log of 100 over, keep accidentally doing ln instead of log of 3. And let's put that into the calculator, just see what we get. So log of 100 divided by log of 3, 4.1918. So that's a pretty basic one. We're going to use common log or natural log on all of these because those are the ones that are kind of easily available in our calculator. Doesn't really matter which one for the most part. Okay, for this second problem, we need to isolate the 67 to the 2x minus 5. That's going to be the first thing that we need to do before we take a log. So we're going to have to subtract 4, and we're going to need to divide by 5.3. So let's go ahead and do that now. Subtract 4. So 5.3 times 67 to the 2x minus 5 equals, what's that going to be, 296. We'll divide by 5.3. So 67 to the 2x minus 5 is equal to 296 over 5.3. And I'm just going to leave that as a kind of ugly fraction there. I'm fine with that because we'll let my calculator do the work later on that. So now I've got finally my 67, the base, isolated. So now is when I take the log of both sides. And I'm going to use natural log this time since that's what I keep accidentally writing anyways. And it really doesn't matter in this case. 2x minus 5 equals natural log of 296 over 5.3. Okay, now we can bring the exponent out front using the power rule for logarithms. 2x minus 5 times the natural log of 67 equals the natural log of 296 over 5.3 still. And now we just need to solve this thing for x. So I'm going to divide both sides by the natural log of 67. And now I've got 2x minus 5 equals natural log of 296 over 5.3 all over natural log of 67. So I'll add 5 and divide by 2. So adding 5 and then 2x equals 296 over 5.3 over natural log of 67 plus 5, and then divide by 2. This is all over 2. So we can actually put this into our calculator all at once and get a decimal approximation. You have to manage your parentheses pretty carefully, so I should just write out what I'm putting into my calculator here. So I'll have open parenthesis, natural log of 296 over 5.3, close parenthesis, divided by natural log of 67. So then I'm adding 5. Now I'm closing my parenthesis that's paired with this one over here, and I'm dividing all of that by 2. So that's what it looks like, what I'm putting into my calculator here. Just scroll back through, make sure I got all my parentheses. Whoops, left one out. Okay, that looks good. So now I've got 2.97835, so I'll round up to 4. So that is about as complicated as these get. I do